Jitter is one of the new analysis capabilities in the MSO8000 series oscilloscope. Using its deep memory and high sample rate, the MSO8 enables advanced characterization of these signal timing issues. Clock precision is critical for high-performance serial data transmissions. Let's look at how the MSO8000's jitter analysis package improves debugging and analysis of subtle timing issues. Jitter analysis is the characterization of the clock timing. Here we are looking at 35,000 clock transitions on channel 1 from a serial data transmission. TI, or the time interval error, is one of the most useful methods for visualizing subtle changes in the clock frequency. The purple math trace is the TI trend. This shows the sum of the errors in the period from the expected clock. Since the errors increase and then decrease linearly, we can tell that the actual clock period is fluctuating between a value slightly longer and slightly shorter than the expected period. We can use this information to look for periodicity in the clock fluctuations. We can use that measurement on the screen in the bottom left, or we can stop this signal and look at the cursors as well. We can move this cursor to the valley and look and note that the signal has a 10 kilohertz frequency. So the underlying clock is moving at a 10 kilohertz period between really two different values. From the histogram below, we can see that this is pretty evenly distributed and consistent. The instrument also shows the long-term statistics for TI, cycle to cycle, and the positive and negative pulse width measurements at the top. These are the most common ways to characterize clock timing. The trend, period, and distribution are excellent visual debug tools designed to help engineers quickly find the root cause of their jitter issues. One of the advanced capabilities critical to jitter analysis is clock recovery. Depending on the signal type, some receivers will read the clock differently. The MSO8000 can use a constant, explicit, or PLL-based clock recovery. If we switch this clock recovery to a PLL-based mode, we can see that gets rid of much of the low-frequency fluctuations from the measurements for this clock. These analysis tools enabled us to determine root cause and ultimately reduce the clock jitter. Zoomed in on our final result, the MSO8000 can characterize picosecond level changes in the clock period. This is well beyond what can be visualized with a standard oscilloscope without deep memory jitter analysis capabilities.